We are going to continue using area. So for this example 4, it reads as a concrete footing that supports a backyard deck is in the shape of a trapezoidal solid. The top of the footing is a 12-inch square. The bottom of the footing is a 16-inch square. The four sides of the footing form equal trapezoids that are 6 inches in height. The exposed surface needs to be sealed with waterproofing. Determine the area of the exposed surface, that's excluding the bottom, of the concrete footing. So here we have this graphic that shows represents what this concrete footing could possibly look like. A concrete footing is often where a deck post would sit on so that it doesn't sink into the ground. But let's point out a couple of things here. These are a trapezoidal solid. We also have a 12-inch square, and a square is a rectangle, but it's a rectangle whose all four sides are equal. We also have a 16-inch square right here, and then the sides are all equal trapezoids, and they have a 6-inch height. So we need to find the area so that to know how much waterproofing is going to go on here. So here we have our square right here. So I'm going to draw a square. And again, a square is a rectangle. It's a rectangle whose sides are all the same. So I'm going to go ahead and put in my corners here. These are 90 degrees, obviously. And then I'm going to have tick marks, and the tick marks are going to be the same all the way around because the sides are all the same. And these side lengths are 12 inches. So the area that we're going to need to find is going to be this right here. This is our top. So since this is a rectangle, to find the area of a square, it's similar to finding the area of a rectangle. That's going to be the area is equal to the length times the width, and the length and width just happen to be the same. So that's going to be 12 times 12. And that's 144 square inches. Now we have these sides, these trapezoidal sides. And there's 4 of them. We've got one right here. Here's another one. And these are all the same. There's a third one that's over here. And then there's a fourth one that's over here. And they're all equal trapezoids. Now the trapezoid has only one pair of opposite sides that are parallel. So they probably look something like this. The sides probably look something like this. So this base right here, that's probably this one right here. That's the edge of one of the squares. So this is 12 inches. This base right here, that's the edge of our 12-inch square on the bottom. That's right around here. Or our 16-inch square on the bottom. So this is 16 inches. Our vertical height right here, our perpendicular height right here, that's 6 inches. So we find the area of a trapezoid. It's similar to finding the area of a rectangle. We have these lengths and these widths, except we call them bases. And since we have 2 different size bases, we have to add the 2 together. And then we multiply that to the height. And since we wind up adding the bases together, we then eventually divide the whole thing by 2. So we take the height and we multiply to one of the bases. We say that base sub 1. We just have a subscript of a 1 and add that to the other base. And we'll just give that with a subscript of 2. And then we divide the whole thing by 2. So we have a height of 6 inches. One of the bases is 12 inches. The other base is 16 inches. And then we divide it all by 2. So this is 6 times 28. Divide that by 2. And that's equal to 84 square inches. So that's the area for one of the trapezoids. But since we have 4 of them, I'm just going to multiply this by 4. So that gives us a total of 336 square inches. So since I want the entire exposed surface except for the bottom, excluding the bottom, that means I add up the 4 sides, which comes out to be a total of 336 square inches. And I add that to the top, which is 144 square inches. So we'll just do that. We'll add those two together, 336 plus 144. That's equal to 480 square inches. And I think we got it.